Hello everyone, this is Colin from Fiber Optics for Sale. In this video, I will explain what is VCSEL laser. So let's get started. VCSEL stands for Vertical Cavity Surface Emitting Laser. VCSEL emits light in a cylindrical beam vertically from the surface of a fabricated wafer and offers many advantages when compared to conventional edge-emitting lasers. Now let's take a comparison between conventional edge-emitting laser and VCSEL laser. The left picture shows a conventional edge-emitting laser. The right picture shows a VCSEL laser. Conventional edge-emitting laser has some disadvantages. The light beam usually has a high divergence angle and difficult to couple into optical fiber without a corrective lens. Also, it requires higher electrical threshold current to operate. VCSEL lasers have many advantages. It has a circular light beam, which is very easy for coupling into optical fibers. It also consumes less power. Since it emits from the surface, this structure can be integrated in two-dimensional array configuration. Now let's see how VCSEL lasers work. A VCSEL laser is typically composed of several layers. The top layer is the electrical contact for current injection. The next layer is a high reflectivity top mirror, which has a 99% reflectivity. This layer is made of DBR, which stands for Distributed Bragg Reflector. Then the next layer is an oxide layer, which constructs a light-emitting window, so the light beam can be optimized into a circular beam. The center layer is a laser cavity. It is usually a multiple quantum well layer. This is an active gain region where lasing actually happens. We will talk about quantum well in the next slide. Then another oxide layer to confine the light. Last is the bottom DBR layer, the bottom mirror, which has 99.9% reflectivity. Notice that this reflectivity is much higher than the top mirror, so that lasing light will get out from the top mirror instead of the bottom. The right picture shows how the lasing really happens. The quantum wells generate photons, which get bounced back and forth between the top DBR mirror and the bottom DBR mirror. This is a typical lasing mechanism as in all lasers. The active region in a VCSEL laser is usually a quantum well structure. This slide shows the basic structure of a single quantum well. This structure can be repeated several times to construct a multiple quantum well. A quantum well structure is made of three layers. The two aluminum gallium arsenide layers are thick, and in between is a very thin gallium arsenide layer. In fact, the central gallium arsenide layer is so thin that electrons cannot move freely in the vertical z direction, but only in the xy plane. This is called quantum confinement. The quantum confinement effect increases the lasing efficiency, which is a big advantage over conventional double heterostructure lasers. The aluminum gallium arsenide layers have a wider energy band gap, as shown in the right picture. The gallium arsenide layer has a narrower energy band gap. This is called a potential well, where the quantum well name comes from. The theory of how quantum well works is much complicated. We cannot cover it here in a short video, but you can research this by yourself in order to fully understand quantum well lasers. VCSELs have high performance and low cost advantages. The key features are: the structure can be integrated in two-dimensional array configuration. Low threshold currents enable high-density arrays. Surface normal emission and nearly identical to the photodetector geometry give easy alignment and packaging. Circular and low divergence output beams eliminate the need for corrective optics. Passive versus active fiber alignment combined with high fiber coupling efficiency. Low cost potential because devices are completed and tested at the wafer level. Lower temperature sensitivity compared to edge-emitting laser diodes. High transmission speed with low power consumption. So there you have it. Please leave your comment below if you'd like to see other topics. Don't forget to visit foforsale.com for more free fiber optic tutorials. I will see you in the next